Hello and welcome to part 3 of the function sketching series. In this video, we're going to be completing the next step after the first 3 steps where I've done videos on those steps. You can check them on the top right hand corner. In this video, we're going to be focusing on the 4th step, and it's going to be a series of 2 short videos. The first one, we're going to know how to determine the horizontal asymptotes and how to determine the oblique asymptotes in the next video. So first, let's start by defining what is a horizontal asymptote and an oblique asymptote. Again, asymptote is a line that the function tends to come super close to, but never touches when x is going to infinity or negative infinity. So if we have a line like this horizontally, our graph is something like this, is going to keep on approaching this line, however, never ever crossing it. So this line is now horizontal asymptote. If we have the same exact thing, however, our asymptote is not oriented in a horizontal way, it's oriented in a slanted way, something like this. Maybe we have a function that looks something like this. Then this asymptote is now called an oblique asymptote. Okay, and in the previous video, we determined what's a vertical asymptote. It's the same exact idea, however, the orientation of the asymptote is different. So that's a vertical asymptote. Okay, let's see what is the way for us to find a horizontal asymptote. First of all, the thing that we're going to do is, let's say we have a rational function. The first thing, we're going to divide every single term by the highest power in denominator. What do I mean by that? I'll show you. The second thing is that we're going to take, after dividing, we're going to take the limit as x approaches infinity, and the answer is going to be the horizontal asymptote, and we have different cases. Let's start by saying that we have a function f of x equals 4x squared plus 12x minus 40 over x squared minus 4. Okay, so the first step is divide every single term by the highest power in the denominator. So what is the highest power of x in the denominator? Obviously, it's x squared. So we're going to divide every single term up and down by x squared. So this is going to equal 4x squared over x squared plus 12x over x squared minus 40 over x squared. Everything over x squared divide x squared minus 4 over x squared. And we're going to take the limit as x approaches infinity. So what happens here? First of all, let's agree on a certain idea. Let's say I have 1 over 10. How much is that? That's going to equal 0.1. What if I have 1 over 100 is equal 0.01? 1 over 1000, 0.001, and so on. So as the denominator value increases, so our answer tends to go to 0. Okay, so as the denominator reaches infinity, our answer is going to approach 0. Okay, so in other words, when we're dividing by an infinitely large number, the answer is 0. Okay, so let's get back to our fraction over here and apply the limit x approaching infinity. Okay, first let's simplify. So here x squared will cancel with x squared. I'll have a 4 plus x will cancel with one of the x's here. I'll have 12 over x minus, this is 40 over x squared over x squared divide x squared is basically 1, and this is minus 4 over x squared. Again, I'm taking the limit as x approaches infinity. So over here, there is no x here, so there is nothing to do. In the second term, when x approaches infinity, it looks something like this, right? So I have something dividing infinity. So this whole thing becomes 0. Again, this is 40 over infinity squared. So an infinitely large number squared, that's huge. So this is 0. Over here, this one, there's nothing I can do because it doesn't have any x in this term. Over here, it's also going to approach 0. So my answer is going to approach 4 over 1, or basically 4. And this is going to be my horizontal asymptote. So my horizontal asymptote is going to equal y equals 4. Okay, so a quick revision, what we do is divide every single term by the highest power in the denominator. So the first thing I identified, okay, this is the denominator, highest power is x squared. I divided every single term by x squared, and I took the limit as x approaches infinity. I simplified every single term, and then I applied this limit knowing that anything over infinity is 0. I cancelled out all the zeros, and I'm left with 4 over 1 or 4. So this is my horizontal asymptote. Okay, let's try and check our answer. So over here, I plotted the function, okay, and let's check the function when y equals 4. We are going to have an asymptote just like what we predicted at x equals 4, which is this black line. So our function keeps on approaching this line as x approaches infinity and negative infinity as well. So this this confirms that our answer is correct, which is y equal 4 as our horizontal asymptote. Okay, let's take another example. So let's erase all of this. Okay, let's say we have function f of x equals 2x squared minus 4x plus 8 over 3x squared minus 27. Again, the first step to divide everything by the highest power in the denominator. So what's the highest power in the denominator here? X squared. So I'll divide everything by x squared, and I'll take the limit as x approaches infinity. So this is going to equal 2x squared over x squared minus 4x over x squared plus 8 over x squared. I'm essentially dividing everything by x squared minus 27 over x squared. Let's simplify. So this is going to equal limit as x approaches infinity of x squared and x squared are going to cancel. I'm going to be left with a 2 minus 4 over minus 4x over x squared is going to be minus 4 over x squared plus 8 over x squared. Over here, I'm going to have x squared and x squared cancelling, so I'll have a 3 minus 27 over x squared. Let's apply the limit as x approaches to infinity. So I can see that this term is going to be 0, this term is 0, and this term is 0, and I'm going to be left with 2 over 3. So my horizontal asymptote is simply y equals 2 over 3. And to check that, we can plot our function over here, and we can plot the line y equals 2 over 3. And as expected, we can see that is it 2? As expected, indeed, as we approach infinity, so as we're approaching an infinite number of x, our lines are approaching each other. So this is a horizontal asymptote. And unlike a vertical asymptote, a horizontal asymptote can actually cross the curve at one point. However, what makes it a horizontal asymptote is that when I'm approaching infinity, when I'm going too far to the right or too far to the left, I can see that the lines are kind of converging and basically approaching each other. Okay, so again, a key difference is that a horizontal asymptote could cross the curve, and we saw that over here. We actually touched our horizontal asymptote and there is no problem in here. However, vertical asymptotes are never ever touched by the graph. Okay, let's try and take another example. Let's erase this. Let's say we have f of x equals 3 over x squared minus 2. So again, let's take the limit as x approaches infinity, and let's divide everything by the highest power in the denominator, which is x squared again. So this is going to be 3 over x squared over x squared by x squared minus 2 over x squared. So this is going to equal the limit as x approaches infinity of, this is 3 over x squared. So when I put an infinity over here, it's going to be a very high value. So this is going to be 0 over x squared divided x squared is basically 1. And then this term is going to be 0 as well. So minus 0. So over here, my answer is going to be 0 over 1, which is equal to 0. So my horizontal asymptote is the line y equals 0. So let's check. This is our function over here, and let's check the line y equals 0 if it's a horizontal asymptote. I'd love another color. So y equals 0. Yeah. So as we can see, again, this is indeed a horizontal asymptote. Okay, let's take another example. Let's say we have f of x equals x minus 4 over x power 4 minus 81. So again, I'll do the same thing. So I'll take the limit as x approaches infinity. I'm going to divide everything by x power 4. So this is x over x power 4 minus 4 over x power 4 over x power 4 by x power 4 minus 81 by x power 4. So basically, this is going to be x cubed, taking the limit 1. This is going to be 1 over x cubed. So this is going to approach 0. This is also going to approach 0. This is 1, and this is going to approach 0. So my answer is going to be 0 over 1 again, which is 0, making y equals 0 a horizontal asymptote. Let's plot x minus 4 over x power 4 minus 81. And, oh, okay, we have the horizontal asymptote line. And as we can see that as we are approaching infinity, we are, our lines are approaching each other. So this makes it a horizontal asymptote over here. Okay. Right. Let me tell you something. If you noticed, whenever the numerator highest power of x is less than the denominator highest power of x, our horizontal asymptote is always 0. Whenever the numerator degree is equal to the denominator degree, the horizontal asymptote always has a value, and it's the value of the coefficients of this. Let's say if it's 4, this is 3, and this is x power 4. So over here, my horizontal asymptote is going to be 4 over 3. Okay, this is just something for you to notice. So let's take more examples, okay, showcasing a very important thing that we're going to talk about in the next video as well. So let's say we have f of x equals x cubed minus 2x squared plus 5 over x squared. So let's do the same thing. Here, notice that the numerator power is greater than the denominator power for the first time in this video. So let's take limit as x approaches infinity of, let's divide everything by the highest power in the denominator, which is x squared. So this is going to be x cubed over x squared minus 2x squared over x squared plus 5 over x squared by x squared. So let's simplify. This is going to be x approaches infinity. So this is going to be x cubed divided x squared is basically x, minus 2x squared divided x squared is basically 2, plus this is going to be 0, so plus nothing, over x squared by x squared is basically 1. Okay, now taking the limit as x approaches infinity is basically going to tell me that my numerator is infinity, so it's basically infinity over 1. In this case, we do not take the horizontal asymptote as infinity over 1 because this doesn't make sense. This indicates that there is another type of asymptote called an oblique asymptote. And I'm going to teach you how to find the oblique asymptote in the next video. However, over here, if the question is asking, is there any horizontal asymptote? Your question is no horizontal asymptote. However, our target is to correctly draw the function, okay? So we will need to know our oblique asymptote. And as I said, we're going to see this in the next video. Something to notice, and I'll mention again in the next video, when the numerator is greater than the denominator by 1, like in this case, numerator is 3, denominator is 2, then we have an oblique asymptote. If the numerator is greater by something more than 1, if it's say this is 4 and this is 2, so the difference is 2 now, then we will not even have an oblique asymptote. We will not have an horizontal asymptote nor an oblique asymptote. So over here, let's test the original question that we solved, and let's see what is happening. So if we plot x cubed minus 2x squared plus 5 over x squared, we will have a function that looks like this, and I can see that the function seems to be approaching a straight line that is oriented, and this is my horizontal asymptote over here, and I'm going to show you how to find the equation of the horizontal asymptote in the next video. The next example is very similar, so let me try and show you that if we have f of x equals 2x squared minus 5x plus 5 over x minus 2, I'll do the same thing as always. So 2x squared by x minus 5x by x plus 5 over x, everything over x minus 2 over x. So this is basically 2x, this is 5, this is going to be 0, this is going to be 0, and this is going to be 1. So my limit as x approaches infinity is going to be for 2x minus 5 over 1. Again, taking this limit doesn't give me an actual value, so no horizontal asymptote. Let me check if the numerator is 1 power up or 1 power greater than the denominator. This is 2, this is 1, so that is correct. So indeed, I will have an oblique asymptote. And let's check by graphing this. If I graph the function over here, again, this seems to have an oblique asymptote over here, which has a function, or it looks like a straight line that is slanted somehow. And over here, just a quick revision. If you notice that x minus 2 is in the denominator, x equals 2 is going to give me a vertical asymptote. So if we plotted x equals 2, again, we have a vertical asymptote. If you want to revise this, I left all the links to the previous videos in the description, and you will see them on the top right hand corner. Okay, let me show you one final thing. So if we have f of x equals 4x power 4 over x squared plus x, I will do the same thing. X approaches infinity. 4x power 4. What's the highest power in the denominator? It's x squared. So I'm going to divide everything by x squared. X over x squared. So this is going to be limit as x approaches infinity of 4x squared, because x power 4 over x squared is x squared, over 1 plus, this is going to be 1 over x. So this is going to be 0, because it's going to be 1 over x, so 1 over infinity is 0, so plus 0. So again, over here, no horizontal asymptote. Let me check the difference between the powers. Numerator highest power is power 4, denominator is 2, so no oblique asymptote as well. And let me confirm that. So if we plot our final graph, we will see that we don't have any oblique asymptote over here in this function. So I hope this video was helpful. I hope you would not forget to like, subscribe, and comment. This keeps me going, encourages me to do more videos for you. Please check the previous videos. I'm gonna do more videos on this series, and the final videos are going to be me sketching from A to Z, showing you how to use these steps to fully and successfully sketch a function. It's very, very important. It's very confusing for students, and I believe that this series is going to help you a lot. Anyways, thank you for watching. Have a nice day. Goodbye.